Okay, let's go ahead and get started on at least the first part of a lecture on chapter 12. Don't plan on finishing this up today, but we'll at least get halfway in. And, you know, the more I kind of reflect on this book and think about what we're about to get into, you know, we wrote a whole lot of code, even in chapter 4, that did a whole lot. And we could code it and it would work. And really, ever since chapter 4, we've just been expanding on that little by little. And also, I would say just offering a better explanation as to why things worked, right? So when you understand the why things work or how things work a little bit better, it just kind of helps you understand the big picture, like how it's all working together. So this is an important chapter for just those same reasons. You know, when we wrote some C# code and it generated a database for us, you know, what exactly was happening, how, you know, just basically getting a better understanding of the code, a lot of it that we've already written, just getting that better comprehension. And so, you know, a lot of the times it was just like, hey, write this code and it works, and then we moved on. But we're diving deeper into a little bit of the, well, how does that work? Specifically with entity framework, right? So EF entity framework. You know, if you kind of start off with like the definition of entity framework is an object relational mapping framework. So you'll hear that called an ORM. And so the OR part makes a whole lot of sense if you stop and think, well, what is an object? Well, we understand classes and objects, right? And we're working with relational databases. So relating your objects to your databases, right? Or when I say related, you're mapping your objects to your relational databases. And so that's what EF is, right? Mapping your C# to your tables, or from your tables to your C#, right? So that when it comes to entity framework, there's really two approaches, and you'll see this quite often. When it comes to EF, and the book covers both of these, there is, I must have not enabled editing. Doesn't matter. I'll just speak it out loud. There's code first entity framework, which is what it sounds like, your objects first, your classes first, and then there's a database first approach. Database first would be like, hey, I've got my database tables and I want to, you know, build an application based on these database tables. So what we've done and what we're going to continue to do is our code first, but we do explore database first as well. So again, we're using entity framework. Of course, the core is the .NET Core version. When I think of .NET Core, I just think of, you know, it's compatible with, the apps you build are compatible with Linux and Mac, and you can build them on various operating systems. So into the objectives a little bit. Okay, so develop a DB context and entity class that define the data for an app and create a database and tables and map to those classes. Well, code first, entity framework, that's what we've done. What, you know, as a foreshadow, what I like about this chapter, again, is it just goes into why things work. And Sam, you come to mind because a lot of what happens in .NET MVC is because of convention. It just, you code it this way and it works this way. It's just kind of magic. And you've expressed on more than one occasion that you don't always love the conventions. In other words, you really have to understand it like forwards and backwards and understand why it works that way to understand why something might be breaking, right? And what we do in this chapter is some of the conventions that are assumed, we kind of explicitly code some things to make the code more readable and more even understandable, so that there's less assumptions that you have to make, which is, as the book refers to, as a best practice. So what we've been doing so far, yeah, it works, but not necessarily a best practice, because it's assuming that you understand a lot of things that you may or may not understand. Does that make sense? So we're going to kind of write some explicit code in our classes that might not be necessary to run our code, but would kind of help you understand what's going on with the database. Okay, and then going the other way, right? Given a database, generate the entity classes, right? So it's basically the objectives 1 and 2 basically say, hey, take a code first approach and generate the database, and then number 2 says you have a database and generate the code. And so in the real world, if you're developing an app from the ground up, you're going to be developing more than likely the code first approach. But sometimes, there might be a scenario where you got a bunch of data in the database and you need to generate an app to interact with that data in the database. And so that would be where you might do this database first approach. Yeah,
when we're making like the DB context files, is that considered code first approach?
Yeah, when you're creating the classes and the DB context. Now, if you have the database first approach, it'll create that DB context for you. That's not to say that you don't have to modify it, because as you'll learn that you do, it'll generate the C# classes and the DB context class for you, and you wind up making changes to them as you need to. Okay, so we already kind of talked about code first development versus database first development. The entity classes, these are the core classes for your app, that actually build your software. These are the custom classes that build your software. And then, of course, the DB context class is how you tie into a database. And so what we also cover in this chapter is a little bit more on LINQ. Like in chapter 4, we get introduced to LINQ, but we didn't do a deep dive, and I wouldn't say that we're still doing a very deep dive, but it's deeper than we have up until this point. And so with these DB context classes, we're going to be exploring a little bit more with LINQ and writing some more advanced queries. And so these 3 techniques you can use to configure a database with code first. There's, just like before, there's like the convention, right? The convention is you code your attributes this way and it generates the table a certain way. Then there are the attributes that you decorate your properties with. And then there's a more advanced technique with what's called the Fluent API, where you're writing a little bit more code to configure. But those are the 3 techniques, right? There's the convention technique, there is the attributes, and then there's what's called the Fluent API. Okay, and then we're going to do a little bit deeper dive into the commands. Like, what commands do we know so far? Well, we know add migration and we know update database, right? And those are pretty much the only commands that when you install Entity Framework from the tools, from the package manager, those are the commands that we've explored, but there's 3 or 4 or 5 that are relevant commands. We'll go through them. Then again, of course, our relational databases have 3 kinds of relations that we've studied before. There's one-to-many, there's one-to-one, and there's many-to-many. And so far, we've only been creating relationships with one-to-many relationships. And so we will explore the other ones, how to create a one-to-one and a many-to-many. And so how can we create those relationships with our classes, right? We create them with our classes, and then it'll ultimately affect our database design. Mentioned Fluent API already. We get into what are the use of partial classes. Now, again, I've been in the C# world for a while, and I've seen partial classes before. But I thought this book did a good job of explaining what a partial class is and what its benefit is. And if you remember, like even second semester or whatever, anytime you would create a form, like you would say a new Windows form, it would be a partial class. And that always made me scratch my head a little bit. Like I would just work with it, and I didn't really understand the difference between a regular class and a partial class completely. And like I mentioned, we're doing some LINQ, doing some Entity Framework with LINQ to do some CRUD operations. And then this concept of concurrency, again, we're not going to get past, I think, maybe the first half of this today, and then we'll finish it, the rest up next week. So like these other things towards the end, concurrency is like, well, what do you have when you have two users trying to update the same information at the same time? Like, how do you handle that situation? That's this idea of concurrency. And then working with something called a repository pattern and encapsulating code. Okay. So, hitting some theory here, we will write some code towards the end here. Let me grab my book and just make sure I got my notes. Okay, so the first slide is a pretty standard couple of C# classes with auto-implemented properties. What can you take off of this? Book ID is going to be your primary key. I think you guys know that. Author ID is also your primary key. As we get into this, right, a book can have many authors and an author can have many books. So as we expand on these classes, you know, there will be more code in these to help us create what's called a many-to-many relationship. And so that's just something that we will be adding to this. Of course, our context files have these two methods, right? On configuring and on model creating. On model creating, that's where your seed data goes. And then on configuring, you usually just provide your connection string in here. However, like the recommended practice, as you guys know, is you put the connection string in the program CS. And so you don't have to put your connection string here. Instead, you just kind of pass it up to base on configuring. Of course, base on configuring, your context inherits from DB context. So the parent, when you pass it up to base, it just passes it up to DB context constructor. So really not a whole lot new. You know, I did take some notes on this one. And it's like, hey, you know, on configuring, again, it's where you can put your connection string in here, but you typically don't do that. And then the only other, you know, note that I took is, hey, make sure to cover what an ORM is, right? C# currently uses Entity Framework, and other languages don't. Like, we didn't have an ORM in the JavaScript world, right? And so whether an ORM is something that, you know, these ORMs are increasing in popularity, like Entity Framework, or they're decreasing in popularity. You know, I think back to Mr. Smith, you know, he would share his opinion that ORMs in general aren't some like savior that they were once thought to be, right? So, anyways, that's what Entity Framework is, and
What would be another example of an ORM?
I don't know any other ones. This is the only one I know. But let's look at other. Let's ask Google. Popular ORM frameworks.
Cake, PHP.
I've heard of Django.
Yeah, me too.
I've heard Django.
I think I've heard of that one.
Hibernate's in the Java world. So you'll hear in enterprise development, Mr. Gegelman did a lot of Java work. Did you work with Hibernate?
No. Spring was probably the closest I came to that. But
Okay.
Yeah, Hibernate was starting to get really popular too.
I've heard of Spring.
So there's your Entity Framework. Here's just some other ones.
So there's Entity Framework and then Entity Framework Core, I guess. Is there a difference?
Well, keep in mind that Core is just like the latest revision of .NET Framework.
Okay.
And so it's just to say like version 4 versus version 5.
So that's the latest.
The latest is Core.
Okay.
Again, I think some of this we already touched on. If you have a property just named ID or class name ID, and case sensitivity, it's case insensitive, right? So it doesn't matter capital letter ID, capital I, lowercase d, capital I, and capital D. It doesn't matter, right? But that's going to be your primary key. And if it's an int, it means it's also an identity column. Identity means basically a unique identity, right? So you can't have two rows with the same identity value. We don't always, like I can think of some labs where our ID column was a string, and when it was a string, it wouldn't enforce that identity column. But if it's an int, it's also automatically generated by the database, aka auto-incrementing, right? It starts at 1, goes up by 1. By default, a string, so a string in C# will map to nvarchar max in your database, right? So just data types. Strings go to nvarchar max. Well, then if you don't want it to be nvarchar max, you could set a string length attribute and change so that it could be 60 characters long or 2 characters long or whatever you want it to be. In your C#, right, your ints or your doubles, they're not nullable by default, which is why you put the little question mark on them and can make them nullable, right? So these are some of the assumptions that you could call the assumptions that just by coding your C# classes, this is the kind of database that it will create, right? And these are the assumptions that maybe you paid close attention to, maybe you didn't pay close attention to. But understanding these assumptions, again, getting under the hood a little bit here, right? Like in chapter 4, we were just running the car, now we're trying to get under the hood a little bit. Yeah.
That was clever.
Yeah. So again, this is by convention. This is one way to code your C# classes. So you got book and then the name of the class, book ID, or just ID, what have you. Yeah.
So I noticed in the last slide it said specifically class name ID is the
Yeah.
primary key.
Yep.
So if the class name was book and you put page ID, that wouldn't work as a primary
Bingo.
key.
Bingo. Good question. So again, you're just going to get some default database design based on the C# that you write in your classes, based on these conventions. Now you want to modify the conventions. Of course, you don't always want exactly what is default, right? Sometimes you want to configure your database differently. And so Ryan kind of mentioned a case, hey, what if I want to name my primary key column something else, right? And I'm pretty sure in this class, I've had some students say, hey, in order to get this to act as my primary key, I had to mark it with this key attribute. Like, have you guys seen this key attribute before?
Yeah, Mel uses a lot.
I want to say that Amel kind of mentioned that. What if you don't want nvarchar max? What if you don't want to? So if you don't want nvarchar max, by the way, strings by default allow you to type in as long as they want. What's a problem with a database that allows anything to be put into it is, well, you might fill up some hard drives, right? Hard drives are generally pretty cheap nowadays, and maybe you don't care about that. But it can also cause performance issues. If you start filling up these tables with lots of information, you might not be able to get the information out very quickly, right? So you might want to cap your data that you're allowing in to something more reasonable. Here, 200 bytes of information, or 200 basically characters, you would say, because I want to say every character is 2 bytes. But 200 characters would be allowed for your string length. And then marking it as required, well, then that would uncheck to allow nulls, right? The database each column either allows nulls or it doesn't. Now, I mistakenly thought let's just add a question mark and make the data type nullable, but that actually didn't change that allow nulls on the table. To not allow nulls, you have to mark it as required. If you leave that off, again, it kind of goes back to the type. A string is nullable, so a string will allow nulls unless you mark it as required, right? So by default, strings are nvarchar max and they're nullable. Unless you don't want them to be, you can use these attributes. And then page 449, if you guys flip to page 449, if you want even more control, so step 1 is convention, right? You got to understand how the C# that you write will create a database table based on convention. And if you want to change that convention, you can use some of these attributes. Key, not mapped, they don't talk about not mapped on here, but not mapped is to say that you've got a C# property that you don't want in your database table. Make sense? Not mapped. It's in your C# code, but it's not mapped to a database column.
I remember using the not mapped before. So but I don't really remember why we used it. So what is the not mapped?
Yeah, so if you wanted in your C# application to have a property, but you didn't need to store that in a database table. So you might have a full name property that you already have the first name and the last name stored in the database. You don't need a full name property. So you might do that not mapped because you don't need to store that information redundantly. Make sense? So if you're not using the attributes, you're not using the conventions, you can use some of this Fluent API. And here's an example of, notice the method, you know where that method is, on model creating. That's where we write our seed data. And notice you're saying, hey, in the book entity, make the title required and a max length of 200. Now, this line of code right here using this Fluent API is literally the same exact thing as using these attributes. So we're not really doing anything different here, just giving the example how it could be done another way, right? And of course, if it can be done multiple ways, developers will do it every way possible, right? They're just going to know what they're familiar with. So I'm thinking, well, especially as let's assume you go out there and see someone else who wrote some MVC code, you know, that there's a chance they use this syntax. And we do a little bit of that here.
So instead of doing it in the model or the class, you do it
In the context file. Yep. And so here's just a little bit more of that flushed out. And okay, so kind of the next place that the book goes is in that context file. You know, if you have like a little bit of seed data, it's not a big deal. But as any file gets too large, you know, there's ways to break it up into smaller chunks. And so the context file, we will do this, and once you do it once, it's kind of like probably like that validation stuff. You do it once, you do it twice, you get the pattern. And so when you have a bunch of entities, we're doing relatively small apps here. We've got 3, 4, 5 entities, but in the real world, you know, I've seen UML diagrams with lots of entities, right? Imagining a context file with some complex seed data, you know, putting it all in one file, you can imagine that file would get pretty complex, right? So they show a technique where you make a class. This class is called bookconfig, and this class has your seed data for your books, right? So notice, you know, internal class bookconfig, we have to implement this interface type book, right? This generic type book. So you're going to make a class called bookconfig. Of course, when you implement an interface, it's going to force you to override this configure method. And then this is really 2 parts. This first part is some of the Fluent API to configure your table. So this is like saying, hey, this is the primary key, and this is this title column, and the seed data. Right? So you're doing table configuration. This is the design of the table with that Fluent API and the seed data. And then you basically just have to call this book config. They make it, now notice on model creating, we just call this new book config. Right? So it would really condense down the code that you would put in your context file if you've got 15 models, right? And they all have a little bit of seed data. You could just break them up into smaller chunks this way. Did I answer your question? Because I saw your hand go up.
No, I was in the configure. Do you have to do those Fluent APIs if you already did it?
No, it's just an example. Yeah.
You would just do the has data part, right?
You would just do the has data. If all you had was seed data and you didn't need to manually configure the tables any sort of way.
Like if you did that in the model already, or in the class.
If you did it in the class, yeah. Bingo. Okay, so this is good because as we're building bigger applications, I think just kind of keeping our code chunks in small, manageable blocks of code is always a good thing. And I will say, just kind of as a heads up, chapter 13 is just a coding one application. It's just like a code along for one application that takes everything, you know, from all 12 chapters and kind of builds it into one. So chapter 13 has a bigger application. I wouldn't call it big, but bigger than what we've been building. Okay, you already know how to get to this window, Package Manager Console. And on to the different commands. Okay, and I think this would be a good spot to maybe do some code demonstration, right? And actually tinker with this. So let me open up.
Should we code along for this, or is it okay?
Either way, it's either way. It's totally up to you.
Not allowed.
I'm just
MVC. So I'm just going to put together like exactly what they've been showing, which is book and author. Really, they've just been focusing on book. But let's add the class called book. And author. Oop. Author ID. Something that I've never tinkered with and I should have tinkered with a long time ago is on my manage NuGet packages. I think if we just install Entity Framework, like the whole Entity Framework core, I think we're going to get the tools and I think we're going to get the everything that we need. No, this just says EF install. EF Core works with SQL Server. I think that's going to be everything that we need. Now, back in book, again, so this was kind of the convention, and they say, you know what, we're going to call this ISBN, and we'll mark this as a key. And as you type in key, notice you got to bring in data annotations, so that's good. And then title, we're going to say required, and string length 200. Now, right now, book and author don't have any relations. I mean, in the real world, they're going to, but we just haven't talked about relationships yet, right? So there's no book ID over here and vice versa. So really, they're just going to be kind of independent tables. I don't think there's any sort of primary foreign key relationships between them yet. So into program CS, and boys, there's ever a page you need to bookmark is in chapter 4, where we configure our connection string and that dependency injection. Page 145. So app settings JSON. You guys are probably copying and pasting this from.
I was just going to say that.
Yeah, it would be wise. Now, what is the name of our context file in chapter 12 that we're going to use? We're going to use jumping around. Just called bookstore context there. Okay, makes sense. Bookstore context. And that's what chapter 13 is the bookstore. Database is called bookstore. Okay, so there's our bookstore context. Let's create this class called bookstore context, so we know that's coming. And let's go inside of program CS. And add that dependency injection. So that's after add controllers with views right here. I'm going to bring in a using statement here, using Entity Framework Core. Now, oh, see, I was trying to shortchange this. Use SQL Server is not available if you don't install the right packages.
Wait, can you try just doing Entity Framework Core dot whatever, like dot tools or whatever you might need? Is that, or dot SQL Server? Because shouldn't it have downloaded like everything?
That's what I thought. But I'm missing a method here. Are you?
I'm talking about online too. Like, can you try adding like onto like Entity Framework Core dot tools or dot SQL Server? I don't know if it. No, yes, it doesn't show. Okay. So we should always just have
Yeah.
those two. Okay.
Yeah. Well, yeah, I was trying to get around that, but so there's SQL Server. Let's go ahead and install Core SQL Server. And there's tools, Core tools. Now it's there. Builder configuration, get connection string. Bookstore context. One more signal. Now bookstore context needs to inherit DB context. To make that happy. So bookstore context inherits DB context. That makes that line happy. And compiling.
Did you show your connection string?
Sure. Okay, and now we're going to use this kind of different approach to like break up the code into a different file, right? So we're going to get our seed data and let's make a new add class. You could even put these in their own folder. But for now, we'll keep them. Entity type configuration book. So you can put your cursor on the hit control dot enter. That brings in the configure interface. And we're going to call this entity. And we say entity dot has key. Get some IntelliSense there. So this is setting it up. This is the Fluent API configuring ISBN as the primary key. Entity property. I got an extra dot. Okay, the title is required and has max length of 200. Here's your has data method. My ISBN needs to go to a string. Anyone ever heard of this book before? Running with Scissors?
I've read the saying.
I've heard the saying. I've never read the book. These are not. There we go. So has data is a method, there's no curlies on it, it's parentheses. So this isn't so bad when we, hey Ryan. We then go back to our context. Protected override void model builder apply configuration new book config. Okay, so we did all that just to eventually play around with these commands, right? To show you how these commands work. So we're at the point where we can add migration. So add migration adds a named migration to the migrations folder. If it doesn't exist yet, it creates it. So what are you migrating? You're migrating from your C# code. What are you migrating to? To a database design, right? So that's what a migration is, right? We're migrating from one place to another, from your C# into your database design. So when I think of these migrations, I think about, okay, these, if there are multiple, these migrations are changing your database design. right? So when we add a migration and we call it an initial, this is the initial database design, right? And if you have more than one migration, then it changes that design as you go on. Right, so let's open up the package manager console and let's see what breaks. Add. So our first command is one command that we're familiar with, add migration initial. And I forgot something. What did I forget? Oh, I need, my bookstore context needs more. Of course it does. So we need a constructor, and we need our tables, of course. Of course. Public bookstore context. Let me minimize that. Now, the on configuring. We always did on model creating. Do you guys remember doing on configuring in the past?
Do not.
I do not remember doing that either. Code that configures the DB context goes in here. In the DB context, the on configuring method allows you to configure the context, such as providing the connection string. Usually, though, you do this in the program CS. Okay, we already talked about that, so we did that in the program CS, so I think we can get by without it. And now let's try our command again. Everyone's favorite clear screen. Add migration initial. Okay. So, as you know, it creates a migrations folder. It creates a file called initial, and this is going to have two methods. It's going to have an up method and a down method. And so all of these migration files have those two methods, an up method and a down method. And so if you run the migration once, it'll run the up method and generate these tables and all these columns and so forth. You can kind of scan this code. If you've ever written SQL code to generate database tables, I don't remember if you guys have or haven't, but of course you can, and your SQL code kind of has these create tables and all the columns and all their data types. Notice the data types on our title and our primary key here. Primary key is the ISBN. So let's run update database. Now one thing that I found interesting about the update database command. On page 453, I'm going to read this about the update database command. Updates the database to the last migration or reverts the database to the migration specified by the optional name parameter. So there is an optional name parameter, and it can revert the database, right? So update database doesn't mean just applying new migrations, but it can also revert the database, which I thought was worth pointing out. If I check to make sure that this all worked, because we did kind of seed our data a little bit differently this time. We've got a bookstore, tables, and we seeded some books. View data. Okay, there's our 2 books. It's also worth looking at the design, so view designer. Now our primary key should not be nullable by default. Title, we configured that to not null. And our price is not null. Why? Because that kind of goes back to doubles, and ints are not nullables, right? So price was a double, not nullable by default. Of course, you can always change these defaults, but that's what the default is. So that's our books table. So that was our initial. Now, new commands, right? So those are the commands we already knew. I just want to run update database again. Database is already up to date. Okay, nothing was really done. If you wanted to revert to a different one, though, we might tinker with that here in a second. So if I go back into here and refresh, obviously my bookstore database is still there, my tables are still there. I'm going to add a property to the book class now. So book class, here's a property. We're going to prop double discount. Okay, add a property named discount to the book class. Obviously, that discount is not going to be in our database design. So we're going to add another migration called add discount. And you could see by running the up, we're adding a column called discount. And if we were to remove this, it would remove the column discount. So it added another migration file. It also creates a snapshot of these different points in time of our database design, and updates this snapshot. So here's our second migration file. Says review the migration file and note that the discount property doesn't accept nulls. So here, nullable false. So discount is nullable false. Change the discount property in the book class to accept the data type of double question mark. So close that up. Discount question mark. Oops. put that on the data type. And add migration, make discount nullable. So as you can imagine, here's make discount nullable that has nullable of true. Right? So add discount says not nullable. Make discount nullable. Now nullable is true. And if we update database, and go into our books design, we now have discount and it's nullable. Now I want to update the database back to the initial. So if I rename this, rename, copy, I just need the initial. So I'm going to update database hyphen name initial, and it didn't know that name. I'm wondering if it needs the full name. So I'm going to put in the whole full name. Sure doesn't.
It would be the space in between database and name.
It's probably one of these spaces. I don't think it's that one. Let's find out how to get this to run right. Update database name. Oh, maybe we just need to do update database hyphen initial. That doesn't seem right. Hold on. Here's what I'm thinking. Rename, copy, the hyphen just needs to be update database hyphen that. Aha, no, unrecognized option. I'm gonna send you guys on a break. When you come back, I'm gonna have it figured out. I hope. So I'm silly. I'm gonna run this command: update database, add discount. So again, I went from initial to add discount to make discount nullable. So I'm gonna update database, add discount. That was silly me. The answer was right in front of my face. So now, if I go to my design of my book. Discount. It went back to the add discount one, right? It still obviously has the discount, but not before it. Yeah. So as it always goes, as soon as I say, okay, you guys take a break, I'll look at this, and then literally I looked at it for one more second. Here's the command, right? It's just I was doing hyphen name. Didn't need the hyphen name. Just run update database, and then the name that you want to revert to. Right, so to revert to the add discount, remember the add discount added the discount column, but it did not allow nulls. Right, so I ran this command, update database add discount, and it essentially rolled back the last migration that we did. So then that's a new utility that we can get out of this command that we didn't have before, is essentially rolling back migrations. We had enough control that it was like, okay, we would just delete what we did before and then add a new migration and it would just have everything. But you lose the history that way, right? You lose the history of all the migrations. This remove migration command removes the unused migrations. At this point, we have one unused migration. That's the allow nullables. So you can see it removes the last migration from the migrations folder, only works with migrations that have not yet been applied. And so at this point, what's the last one that we have? The last migration is this one right here, and it has not been applied.
Do you apply it with update database, I assume?
If you wanted to, you could run update database and it would apply it.
Okay.
But in this case, if we want to demonstrate the remove migration command, we could do that one next. And it does the same thing as just deleting it. Yay, we can delete from the command prompt. Okay. What else is there? So we've learned a new way of using add migration. We've learned remove migration. No, sorry, we're going to learn the new update database. Add migration is just the same. Drop database. Well, we've been doing that. Right? We know how to drop the database. Now, when you have open connections and this kind of thing, like notice I've got the designer open, like I would probably start by closing all the connections here, close all tabs, and probably close the connection here, right? Make sure you don't have anything open, and see. Drop hyphen database. Pretty dangerous command, right?
I do that good job.
When I was a student, one of my lab partners, we learned DOS. Like that's seems like it was a long time ago. And all the DOS commands, the command line commands, and there was a DOS command called deltree. Deltree was delete the whole tree, right? So it's to like go to the root of your C drive, and deltree /y was like don't prompt, just delete everything. And I have memories of students in my class like drawing like deltree art and like tattoos around the DOS command deltree and like nukes going off and whatever. Just old memories of mine. This is a deltree. This is performing the operation yes to all. How about that? Default is yes. How about yes to all? There we go. Successfully dropped database bookstore.
But then just do the same thing as
Yeah, just doing it this way. So if I refresh, no bookstore. If I bring it on back. So, of course, that's drop database. script migration. We're almost done with these commands again. And then we get into some different relationships. Script migration. Yeah, Ryan.
So if you had a migration, or so you have your database and you create like a new user in the database, and then you go and you change something about the user class, and you add a migration, is that gonna mess up or interfere with the content you already have in the database?
It could. It could. I mean, it's pretty savvy, and I don't know if you paid close attention, but it would do updates and not interfere with the old data. I from what I've seen, you know, the update logic, it shouldn't mess with the code, but you just always have to be aware that it could. Does that make sense?
Yeah.
It's a good question. And again, just from our little exercises today, I remember it was like the SQL commands were updating around the data as opposed to losing any of it. This script migration tool actually gives you this is kind of cool, right? This is actually the SQL script to generate your database. And there's our seed data right there. So that's a useful command. And then the last command, scaffold DB context, that's something that is used in the database first, right, to generate a context file and models based on a database design. Right, so this last one is the database first, right? It would generate the other files. So some different, we just ran through all those. Migrations folder, reverting changes, removing migrations.
A lot of this with the commands was very review, updating the,
Yeah. This is an interesting one. This is another kind of reminder of to revert all the changes that have been applied to the database by running the down method in all the migration files. Enter this command: update database 0. So this is another kind of dangerous command: update -database 0. So if I again kind of look at our bookstore and view data, let's update 0. There you go. Drops all of the tables. So just another command to be aware of. It's funny, just by putting a 0 on there, it basically drops everything. Okay, types of relationships, right? So this is just relational database fundamentals. You've got one-to-many, you've got one-to-one, you've got many-to-many. These relationships are bi-directional, right? So to say, you know, one entity can have many of another, and that any one of those can only have one of the other, right? So one-to-many is both ways. And so you know, to put it better, right? Because that was a terrible explanation. One genre can go to many books, but a single book can only have one genre. So you actually don't see it represented in the way that's drawn there. A lot of times in the notation, a one-to-many is drawn like this, one-to-many going that way. And one-to-many going that way. So this one entity can have many of these, and one entity here can have many of these, right? So it is a bidirectional relationship. Is often how you see it referred to. It's also worth noting that it's really up to the business rules in many cases on how the relationships exist in their company, right? They can differ from company to company. Can a purchase only be bought by one customer, or can a purchase be bought by many customers, right? Because there are like crowdfunding solutions, right? Where a bunch of people can come together on an Uber and buy an Uber ride, right? So again, a purchase being one thing, does it belong to one customer or many customers? That can vary from business to business, right? So these relationships between entities are dependent on the business, and so it's not like a one case is always going to be that way. If you have two different entities, it can be different. And so what we've done so far is one-to-many relationships between our entities, but we're going to code some one-to-ones and some many-to-manys. Now, just like before, you can code these relationships with conventions, you can code these relationships with attributes, and you can code these with the Fluent API, right, to code these different relationships. And so we have not coded relationships with attributes yet, but you can, and these are those attributes. Be it a foreign key attribute, so like in this case the genre has a genre ID inside of book, and by convention the name, it's going to figure out that that's a foreign key. However, you could also mark that property with the foreign key attribute to kind of explicitly code that out. There's also the inverse property, which talks about the navigation property. Remember, you might have an entire genre object over here inside of book, right? And that's referred to as a navigation property that helps it link it back to the genre table. And if you do have that genre object over here as a property, you can mark that as an inverse property to mark it as the property on the other side of the relationship. And then there's a bunch of API methods to mark these relationships as well. They point out that with this Fluent API, when it comes to the relationships, they have this convention with it's called a has-with pattern. If you see all of their methods either start with the word has or with the word with. The has represents the side of the relationships where the configuration starts. The with represents the side of the relationship where the configuration ends. Oh, there it is right there. You could see that. So as we get into that, you could see again if it starts on one side, it's you'll start with the has one versus the with one, and so you'll see some examples of this. And so I don't think we ever did it so minimally where, okay, so again, what we're doing here is a one to many, right? One genre can belong in many books. And you could just code the genre, what they call the navigation property, and not include the genre ID. I think we always at least included both. We included both the genre object and the genre ID object. So notice the slide title is that by convention, like you could code a one-to-many relationship this way at like the bare minimums. This next slide, the title, how to fully define a one-to-many relationship by convention, and it says recommended. So again, I think this kind of, even though it might not be necessary, it is a bit explicit and it can help you really understand the relationship both ways between the entities. So here, again, this navigation property and a foreign key property, this is what we're used to doing. What we're not used to doing, I want to draw your attention to the genre class. A genre has a collections, in this case, think of it, a collection. Why didn't they just use a list, right? Because a list is a collection, so why are they using a hash set? A hash set is a C# collection that doesn't allow duplicates. So it's going to say, hey, I can't have the same book twice in my collection of books. And so, yeah, Vinny.
Is that similar to like a hash map in like Java?
Yeah, so just because it's got the word hash, hash map in Java.
I have worked with those before, and they were not my favorite.
A lot of times when I think of like all these other collections, they're always key value pairs. A map, as you might know, is a collection of key value pairs. Cannot contain duplicate keys. A hash map cannot contain duplicate keys. So it does seem pretty similar, right?
Yeah.
And that here are hash set of books. So again, thinking about this, a book can have a single genre. So that's a book can have one genre, and a genre can have many books. We never explicitly had to code that before. We would code the collection of books here. The navigation property, right? We would have maybe a list of books or what have you. But a lot of times we didn't initialize our navigation property in the constructor. So again, I think I called out Sam in the beginning of this. It was like, hey, there's a lot done by convention. This might help you see, versus something like this, right? This is something that's a little bit more explicitly coded out to get your one-to-many relationship between book and genre. So again, but this is still by convention, right? It's just going by the IDs for the foreign key property, so on and so forth. This would be a one-to-many with attributes. So again, book ID, category ID is going to be our well, why category ID? Well, category ID, instead of giving it the name genre ID, we're calling it category ID. I'm getting crossed right now. Give me just a second. Okay. So it's still one-to-many with attributes. So this is our navigation property for the genre class, but we're calling it category. And it says inverse property of books. Well, books is the property here. The inverse property of category is this one right here. So we have a collection of books in our genre. A genre can belong to many books, but a single genre. So the idea, the reason why they're marking these with the keys is because they're naming their genre as category instead of calling the genre, right? Genre, that's the convention. Genre, right? So since they're wanting to name this property called category, well then you have to spell out, the linking between these two collections, if you will. In this case, the collection is books. So the property in the other table is the books property, and this books property lines up with the category property in the book table. There we go, category ID. Now, this I think is this category ID and book class. To me, it makes sense, and the book does it. To me, it would make sense to mark this foreign key property above this category ID. I think that's the part that's throwing me off. Is that this category ID right here is the foreign key property. But again, so it kind of made me stumble a little bit here. But the idea is basically this. Your genre, you wanted to name your property something different. You didn't want to call it genre, you wanted to call it a category. And for that reason, you have to be a little bit more explicit in how these two things are linked together with these attributes. Yeah.
So because the foreign key means it's the primary key of a different table, right?
Right.
But the other table is called genre. So I'm confused on why it's saying category ID. Is that just like a the name is actually.
Well, this
genre
category ID right here is the foreign key
for genre.
for genre ID.
So is category ID just like a different name? But
It's a different name
it
for it.
means genre ID.
Bingo.
Okay.
Bingo. Yeah, they don't have to have the same column names. It's pretty traditional to have the same column names, but it's not. That might not always be the case. So again, by convention. Then there's like by convention that's recommended, which is a little bit more explicit. And then if you want to change the column names, you might decide to decorate it with some attributes here. And then you can also build a one-to-many relationship. So one book has a genre, and that genre can have many books. So this would be with that Fluent API to define that relationship. Now, author and book is a many-to-many relationship, so I don't have a one-to-many relationship here, so I'm not going to demo one-to-many, but it does get into, well, here's another example, a one-to-many by convention. This is a one-to-one. This is not a one-to-many. So, kind of an interesting thing when it comes to one-to-one relationships. On page 460, I highlighted this little note. It says, if an entity has a one-to-one relationship with another entity, the data in the two entities could be stored in one entity. Right? So if you think about author and author bio could be just its own column inside of author. Right? So a one-to-one relationship is when you could take the two different tables and you could put it in one. So when do you really want the one-to-one to exist? Why would you take something that could be stored in one table and stored in two? They go on to say this is useful when you need to store large objects such as images, sound, and video. Right? So as an example here, they show this example of a one-to-one relationship, an author with an author bio. And you can see on the author table there's an author bio, and on the author bio you have an author. But just a little bit more of like the theory behind when do you want a one-to-one relationship.
I feel like we did something similar in last semester when we had like teacher can also be like there's one teacher that can have many students, but there can also be like many teachers that can have many students in the same.
We did these same relationships. Now, you didn't mention a one-to-one relationship, but we did.
Mm-hmm.
We did this. So what do you see here? You see a navigation property. You see a navigation property and a foreign key property on this one. So one-to-one. You can decorate it with attributes as well, and with the Fluent API. So one-to-ones are really quite similar, except for instead of having collections, like when you have the many, you have the genre that has a collection of books. So a genre can have many books, but a book only has one genre. Right? So there's no collection when you have one-to-one relationships. You have navigation properties, you have foreign key properties and navigation properties, no collections. Okay, now the one that I think is a little bit more common, right? One-to-one's not super common. One-to-many is pretty common. Is many-to-many relationships. You guys got to remember from a year ago, right? When you have a many-to-many, generally speaking, what you wind up doing is you wind up breaking that many-to-many relationship up, and you make what you would call a join table. I think it goes by a couple different names. Like one name is a join table or a linking table. And so, if I were to draw, like if you had just a many-to-many relationship, right, which is essentially what we just had. What you wind up doing is you break it up and you add a third table in the middle. And this becomes a one-to-many here, and this becomes a one-to-many here. Okay, so a many-to-many in database design, when you're going through this process called normalization. Normalization is this, you're taking these different steps to kind of get your database in a good form. One of the steps in the normalization process is eliminating many-to-many relationships and creating these join tables or these linking tables, right? So if I have books, this is books and authors are, what's the example they do? Books and authors. Okay, well, a book can have many authors, and an author can write many books, right? And so that could be a many-to-many relationship. And so typically what you do is you still have books, you still have author, and then you have another table called book author. And book author is that join table. Is this, you guys familiar with this process by now, right? It's like the third time you've heard this. Right? You heard it in second semester, you heard it in third semester, so now you're hearing it again. So like book has book ID of 1, and author has an author ID of 1. So to connect your books and your authors, you're going to have a book author table that'll have a book ID and an author ID. So you say book ID of 1, author ID of 1. That's how you put the two together. Yeah, Vinny.
So when we're making these like context folders inside of Visual Studio, it's just doing all this for us, essentially.
But we haven't done many-to-many relationships yet,
Okay.
right?
Mm-hmm.
So yes, it will do it for us, but we just haven't done many-to-many relationships. Everything we've done so far has been one-to-manys.
Okay.
Every relationship we've created so far has been one-to-many.
Mm-hmm.
And so the reason I talk about this, and the reason the book talks about it, is yes, it will create that join table for you. Okay, but you got to know that it's creating that join table for you so that you, for example, if you're going to seed that join table, how are you going to seed that join table with data?
Right.
To say what book was written by what author, so on and so forth. Okay, so what you do is you put a collection on both sides. And so on the book side, we have a collection of authors, and on the author side, you have a collection of books. So you put a collection on both sides. Before there was just a collection on one side. A one-to-many, you just got a collection on one side. When you have a one-to-one, there's no collection on either sides, right? But now we're going to put a collection of both sides. We've got a collection of authors, we've got a collection of books. Notice it's doing the, in the constructor of the class, it's kind of spelling out that each book has to have a unique author, or a unique list of authors, a unique collection of authors. Like we wouldn't have repetitive authors. You wouldn't list the same author twice of the book, in other words. Same thing, that's why they're doing these hash sets, right? An author has their own set of books, but you're not going to list the same book twice under an author. Okay, so this is how by convention you can set up. And here is the join table, aka the linking table that it will create for you. It'll create a column called author book. So what do I have in my example? I think I have a many to many. Yeah, I got book and author. So let's kind of flush this out, right? Just as they have here. Our book is going to have a collection of authors. So book, public I collection of author, called authors, get and set. Okay, now this is called a skip navigation property. The reason they call it skip, that word skip just means that it allows you, it's going to skip that join table. It's basically going to handle it for you. It's going to create the join table for you, and it's going to kind of skip over it. You don't really need to go through that join table. Again, it also, in the constructor of the class, which we didn't have yet, we return the property authors and new hash set of authors. New hash set of author. And again, you don't really need this constructor. This was all kind of it would happen for us behind the scenes, but you can see we're initializing this list of authors to be a hash set. What does that do for us? To make sure they're unique authors. We're going to do the same thing on the other side. So we have a collection of authors, and on the other side we're going to have a collection of books. I collection of book called books, get set. Public author. Here's our constructor. We're going to set books equal to a new hash set of type book. Okay, so now we got that set up both ways. Now, we have a many-to-many relationship, and I'm going to our database design is no longer valid, right? Because before, these tables had no relationship between them, and I just changed that. So I'm actually going to delete this. I'm going to delete my database. And the migrations no longer needed. I'm going to skip ahead a little bit because again they talk about many-to-many using attributes and many-to-many using Fluent API, but I didn't do either of those approaches. I want to talk about this. How to see data in the linking table for a many-to-many relationship. So keep in mind that there's a convention that we're using, and that convention is going to create a table called author book. Right, so we've got a many-to-many relationship between these two tables. It's going to create a linking table called author book, and by that convention, it's going to be authors, author ID, books, book ID. Those are our column names. Right, so when we're seeding data, we're going to seed data into that table and into those columns. We have to know the table names by convention is authors plural, the authors table, and books plural, the books table. And so notice down here with our Fluent API, right? We'll have to go ahead and create our authors, create our books, which right now we don't have any authors, we only have books, right? We have a book config, but we don't have an author config, so I'm going to make an author config. I'll make a couple of authors, and then I'll link the two together using that Fluent API, right? That's kind of where we're at. And by convention, again, books, book ID, authors, author ID. So let's go ahead and make an author config. Let's add a class called author config. And inherit from this class and implement that interface and bring in some seed data. And our author will be my one author. Let's bring in a second author. Anyone got a favorite author?
Hunter S. Thompson. Which is kind of crazy.
Thompson, T-H-O-M-P.
Mm-hmm.
Cool. Okay. So we got an author config, and back in our context, bookstore context, let's say model builder apply configuration new author config. Now, I'll go ahead and just put a little bit of code inside this on model creating, because that's where they have that. Let's see, model builder entity. let's go back. Sorry. Model builder. I was doing it right. Model builder. Entity. Book. Has many. With many. Using entity. This is where the convention, you have to know the column names. Syntax is known here. Good. An anonymous object. Books. Book ID equal to 1. Authors. Author ID equals 1. So our book config is The Hobbit. Author ID of 1. And we'll just say that this other guy wrote our second book. So our author ID of 2 wrote book number 2. Book ID of 2 was written by author ID of 2. Again, this is based on the conventions that are kind of defaults. So see what breaks.
Are you missing the A dot books from with mini?
Oh. Did I?
Did you run add migration?
Yeah, add migration initial. That was okay, books ISBN is required. That error message makes sense because back here in book, we changed our book ID to ISBN. Let's just change it back to book ID. We were going based on the normal convention, but we changed that normal convention, right? So let's just change this prop int book ID. There we go.
In that case, we don't even need that key property, right?
That's right. We took, yeah, I got rid of the key property. I'll just go back to the convention of book ID. Right, that makes sense. And I think that was the only change I made. I just changed that back. that shouldn't mess with it. Let's try it again. And let's just do a build, because I'm sure I broke something else by doing that. And let's get an error list. Or you keep the ISBN and you just seed it based on that. So let's do that. Let's keep the let's keep the ISBN, because sure, why not? I'm not sure what I want to do. I'm kind of going back and forth in my head. So if I keep the ISBN, then we need to kind of come in here, and we need to say books ISBN. And give the first book. Hey, Scott. And then this book's ISBN was different. There we go.
So that wouldn't be auto-generating, right? You'd have to input that yourself.
Yes, sir. Yeah. And so let's see if that at least gets rid of that error message. The entity for type book cannot be added because there was no value provided. Required property ISBN.
Why wouldn't it be book ISBN, or is it? Because it's just.
I can see where that's. The seed entity for book cannot be added because there was no value provided for required property ISBN. Okay, book config ISBN, there it is right there. ISBN. Just clear it and just make sure that's what I'm seeing. No other error messages, just that one. The seed entity for type book cannot be added because no value was provided.
Do you maybe need to call the migration something else? Because, like, I know I used to get errors about that. Like, if you called it initial more than once, and there was already one in there.
Well, I deleted it.
Oh, you did, okay.
I wouldn't think
That
so.
never.
Okay. Now it's authors, author ID, books, ISBN, books. I could take it back to the author ID. I just thought I'd try and keep it with the ISBN. So let's bring it back to book ID.
Did you look at page 465? Because there was like, when all the configuration is done with Fluent API, and it talks about the has foreign key.
So that's what I'm looking at right now. I'm looking at the top one. It says how to seed data in the linking table for many-to-many relationships when a relationship is configured by convention or with attributes.
And we did it by convention.
And that's what we did both convention and attributes. Right? Because that ISBN was an attribute that
I
we
got
were using.
my migration with the ISBN.
You got your migration with the ISBN?
Yeah.
Get out of here. What am I doing wrong? You're following me and yours works.
So did you use attributes and the convention? Or with many?
We're close. I don't know what's wrong. So author. Book config.
Oh, do you need to have like the ISBN in the author? Because they have
That's a letter.
oh, maybe not. Never mind.
Your string is ended.
Sorry?
Your string ended. I'm just looking for something.
Well, here it is.
But isn't it line
After
6 and 8?
Yes, line 6 and 8.
Oh, okay.
So on my author config, I had the wrong type. And that's what broke it. So typos happen to us all. And that just burned 15 minutes of our day. Thank you for your patience. And watch I say that's it. That is clearly a problem. Hopefully, let's bring this back, and let's bring that back. Let's bring that back. Okay, let's just do a build. Build succeeded. Deleted my migration. Let's run it again. And it worked. And now let's update database. And we have a many-to-many. Foreign key, author books, ISBN, the conflict occurred in bookstore, table view. See, I was trying to get fancy with it, doing the attributes. Let's take a closer look. I know it's a typo somewhere. I don't know where. I'm going to wave the white flag for now, and just to make this book ID. And then refactor this in a couple of places. Books, book ID, books, book ID, the first book, and the second book. Book config. Oh, I commented out the ISBN. There what was. I'm waving the white flag and then I see it.
No, don't wait for my
Don't wave the white flag. Don't do it. Undo. Bring you back. guys are my students, you know, you're kind of forced to be here. I mean, you're choosing to be here, but you're kind of forced to be here. I'd be really surprised if I ever throw this stuff out on the internet and anyone other than someone in my class is watching at this point, because there's so many, so long. You know?
To be fair, I've seen other people on like YouTube videos that have gone through like, you know, and obviously they edit it, so.
That's the thing, they edit it. That's what I would need to do. Okay, clear the screen. Let's see if I have any migrations. Let's delete them.
Honestly, all you would really need to do is just pause it whenever you realize you're having a problem, and then when you solve it, just click.
I do that a
play.
little bit. But we're still on 2 hours in. Hey, I had two mistakes that took a while. Let's take a look at this database. We have a many-to-many now. Apologize for the bumps. But the last mistake the first mistake, in summary, if you're at all interested in learning from my mistake, is I got copy and paste victim, right? I was copying from my book config, and I copied over the type of book into the author config. So I was a copy and paste victim. Have we all been copy and paste victims before? Absolutely. So I was a copy and paste victim. The second mistake that I made, that in my troubleshooting, I commented out an author. And so there was no author ID of 2, there was just one author. And so when I went to insert this seed data with an author ID of 2, there was no author ID of 2. Those were my 2 mistakes. In the Object Explorer, Databases, Bookstore, there's our join table, author book, right? And if I view the data there, author ID of 1 and 2, and then book ISBN of that string. Thank goodness we have a many-to-many relationship. And that's as far as I wanted to get today. I take that back one more slide. This is an interesting slide because think about this, right? Let's just say you delete an author in your database. Do you therefore need to delete all of their books, or do you keep their books? Right? Because books have authors. So if you delete the author, should you also delete the book? And so there's basically, you can either allow that to happen or you cannot allow that to happen. If you allow that to happen, you delete the author, you also delete the books. Okay, that's called the cascading delete. Right? You delete one, it implies automatically deleting the other. That's the default for Entity Framework, is that to allow cascading deletes. SQL Server, if you remember, doesn't do that kind of by default. Right? By default, if you try and delete a customer that has a purchase, and they no, you can't, it's not going to cascade. It's not going to delete the customer until you delete all the purchases first, and then you can delete the customer. And so that's the first concept. You got to understand what a cascading delete is. A cascading delete basically deletes all of the children if you delete the parent, right? So all of our foreign keys, you know, will do that, right? So if you have a parent, like one-to-many kind of relationship, be it a student can enroll in many classes or something like that, You delete the student, you also would delete all of the enrollment of the students in those classes. Of course, you can change that. So in this case, the other option, instead of allowing that delete to happen, you can restrict it. And so ultimately this is the way to change that. The default is to cascade the deletes. The other option would be set null. And so it's like, hey, you can delete the customer, and then in the customer ID column in the purchases table, it would just be null. Right? So I guess you would either cascade the deletes, you would set it null, or you would restrict. And in the case of restrict, it throws an exception and it doesn't allow the cascade to occur. Right? So you guys have seen the end result of those exceptions being thrown when you're trying to delete something and you're not allowed. You get this error message that says, hey, not allowed to do that. So kind of looking at this little chunk of code, and then there's a bookstore database class. I'll have you guys kind of code along with me after this. Thinking about back to this. A book has a genre. And if you were to delete the book, it would not also delete that genre associated with it. Oh, I'm sorry. If you delete a genre, that has related books, it would throw an exception. Right? Because it would say, hey, you can't delete a genre that has a book that has those genres. Right? Because that's dependent.
And that's what restrict does.
That's what that restrict does. Right? Like, hey, no, there's a book that exists with that genre. You can't delete the genre. But otherwise, you think about it by default, and it's kind of risky behavior. You delete the genre and you delete all the books with that genre. Right? Risky behavior.